Hello, everybody. My name is Eli Scott. I'm the Scott and Shasta Watersheds steward with the North Coast Regional Water Quality Control Board. I'm going to talk about drought and water quality in the Scott and Shasta watersheds and some data that we've collected and things we've learned in the last 3 years. And I just want to say, condensing 3 years into 30 minutes is going to be a challenge. I think I've been able to do it in my practice runs, but we'll see how it goes, so just bear with me. Today, I'm going to basically talk about some of the basic watershed characteristics of the Scott and Shasta, what makes them unique, and sort of what opportunities they have that are similar. The recent hydrologic history, which means I'm going to be talking about how bad the drought was, the response to the drought that all of the agencies that work in these watersheds kind of stepped up to work with the community on, and then also some water quality observations from a couple of occurrences that happened during the drought. So first off, we're here at KBMP, we're in the Klamath Basin. You all are in the Shasta, and we're going to be talking about the Scott and Shasta. So just looking at this map, you can immediately see the hydrologic differences between the two watersheds. The Scott is predominantly a snowmelt fed system with lots of small tributaries that feed that snowmelt into the main stem and then out into the Klamath River. The Scott does flow north, as does the Shasta, which can be a little confusing sometimes. The Shasta, on the other hand, is a volcanic spring-fed system. Actually, the biggest spring is coming out right under the first A in Shasta on this map. It's called, appropriately enough, Big Springs. And it's actually a complex of springs that convey snowmelt from Shasta, maybe Goose Nest, we're not super sure about that, into Big Springs Creek, and then eventually into the Shasta River, right in the middle of the desert. So it emerges in the middle of the valley, and that's where the majority of flow comes. Both of these watersheds are natal streams for Chinook salmon and Southern Oregon, Northern California coastal coho salmon. They provide unique climate-resilient cold water sources. One thing that the Scott has that the Shasta doesn't have also is this deep alluvial basin that, allows some of the gaining reaches of the Scott to really have some cold water inputs when there's sufficient water to feed them. Both watersheds are rural with a largely agricultural economy, and they've been impacted by legacy mining, timber harvest, and ranching. And they are impaired. The Scott's impaired for temperature and sediment, as well as biostimulatory conditions. That was a listing that popped up in 2012. And the Shasta is impaired for dissolved oxygen and temperature. And they have TMDLs for in the Shasta for dissolved oxygen and temperature, and the Scott for sediment and temperature. And we're working on gathering data around the biostimulatory conditions listing to see if that needs to move forward with the TMDL as well. There are also ongoing impacts due to some current ranching practices, but not all of them, rural roads and also timber harvest. So getting into the hydrologic history, I follow 2 snow pillow gauges and general weather stations pretty routinely on a almost daily basis. They are located in the southern end of the, put my pointer on my other screen, the southern end of the watershed. So Middle Boulder 3 is this top snow pillow. Scott Mountain is this bottom snow pillow. Snow pillows are a little bit different from snow courses. They actually measure, I believe they measure, I've never been to one, the weight of the snow that falls on top of them and translate that into a depth and then translate that into snow water equivalent. And so you can see here in 2020, Middle Boulder was below average for snowmelt, or sorry, for snow water equivalent, and Scott Mountain was also pretty well below average for snow water equivalent. But I want to pause here to move to this map because this kind of shows all of the data sources that I'm using in this presentation. So these black triangles are weather stations. I use Collins Baldy here at the northern of the Scott, Quartz Hill in the center of the Scott, and the CHA gauge, which is called the Callahan gauge, but I think is in Sugar Creek for my rain data. Middle Boulder and Scott Mountain, like I said, give me snow pillow data. Brazy Ranch is up by Yreka, and that gives me rain data. Weed Airport gives me rain data. These stars are all the biostimulatory condition stations that I have set up and have at some point pulled data from. So they have dissolved oxygen, temperature, nutrients collected on a bi-weekly basis. And every 5 years, I try and get out there and do a CRAM survey. And then these sort of fuchsia dots here are water quality stations that I'm pulling some analysis from for this presentation in the Shasta that collect temperature and dissolved oxygen. So you'll see a transect later on in the presentation. That's where these dots come from. This one right here is super important. This is Salmon Heaven, which is an area of known cold water refugia in the upstream end of the downstream canyon of the Shasta River. So that's been a really important point. It is a temperature compliance point in the TMDL where we looked at, and I'll get into this a little bit later, the temperature impacts of our compliance scenario that shaped the goals of the TMDL. So with that said, moving on to the snow course information from 2020, just really want you to focus. I know these are busy tables on the circled area, which gives you the April 1st average snow water equivalent. So you can see in 2020, for the Shasta River Basin, we were 53% average on April 1st. And in the Scott River Basin, we were 49% average on April 1st. So pretty low numbers. Here's 2021. Just going to look at this quickly. Snow pillow was still well below average at both stations, Middle Boulder 3 and Scott Mountain. And then if we look at the snow course, still below average, not quite as bad as the year before, 84% in the Shasta, 73% in the Scott. Then where things really hit the fan was in 2022. Really low snow numbers at both stations, almost, most of it also melting off pretty early at the end of March. And then you can see the snow course information, 32% in the Shasta River and 27% in the Scott. So very, very low numbers. Here's some rain data collected at those rain gauges I mentioned before, really focusing on the period after 2019, so 2020, keep pointing at the wrong screen, 2020, 2021, 2022, below average for all of the stations across the Scott and Shasta, indicating that, really snow, it was really up to snow to provide a lot of the moisture in these watersheds after these storms came in. There wasn't a lot of soil moisture from snow. So in 2021, the spring of 2021, interagency conversations began. Some NOAA staff gave me a call and sort of initiated those conversations. We started having group agency calls in the spring of 2020 with CDFW, NOAA, tribes, other watershed partners, the Divisional Water Rights and Regional Water Board, and I was the one organizing those calls. Our goal was to delineate regulatory responsibilities and identify gaps in responding to low flow conditions, especially during drought years. And we just continued those bi-weekly to understand watershed conditions as they developed and figure out what we could and couldn't do. This also triggered a government-to-government meeting with multiple tribes, including Yreka, the Quartz Valley tribe, and Karuk tribe, to also sort of formalize that. They initiated that with NOAA, CDFW, the Regional Water Board, and the State Board to really figure out, what could be done, what are the short-term actions, what are the long-term actions, and where do people's agencies' responsibilities lie. And that flow group continues to this day. It's expanded, as you can see from that list, where I see a couple of spelling errors, but it continues forward with a pretty big group of folks, including irrigators, including RCDs, tribes, all the agencies that have responsibility, and some groups that represent both environmental and agricultural concerns. So then Governor Newsom in 2021 initiated the emergency drought proclamation, from which the state board moved forward to adopt emergency drought regulations. They went into effect August 30th of 2021, and then were updated when they were readopted in July 29th of 2022. They provided emergency minimum flows in the Scott and Shasta with the goal of supporting all life stages of salmonids, and myself as regional board staff formally dedicated half my time to work with the state board on that, then pulled back to 40% of my time, and now I'm just doing advisory work. The reason that my time was diverted was because there was an opportunity to establish in-stream flows in support of TMDL goals, and if the TMDL and water quality wasn't at the table, we could see that aspect not being fully considered. And both of these TMDLs in the Scott and the Shasta point to flow as one of the drivers of the impairment. And we collect a lot of data in these watersheds, as you saw from the map that I presented with all those water quality stations in both the Scott and the Shasta. And so being able to have a greater understanding of what tools could be applied to increase flow and what gaps may exist to inform longer term decisions, while also collecting the data to see, like, what's the actual in-stream impact of implementing these different tools, is a huge opportunity. So my management said go forth and work with those people over there. So what tools did we get? First off, curtailment of surface and groundwater, including overlying groundwater diversions. One thing that's important to note in the Shasta is, in both watersheds, these curtailments went in order of priority based off the adjudication. And in the Shasta, the lowest priority water user and diverter is Big Springs Irrigation District as an appropriative groundwater user. They sell their groundwater to their users, and they switched from a surface water diversion to a groundwater diversion, I believe in the 80s, I could be wrong about that, which just made them the lowest priority and the first to be curtailed. So we know from multiple lines of evidence, or I should say we think from multiple lines of evidence, that Big Springs Irrigation District is connected to the Big Springs complex via Pluto Caves basalt. I don't have enough time to really get into all that, but I'm happy to answer questions about it later. So maybe there's a big plug of cold water that's suddenly going into the system that wouldn't be going otherwise if they were extracting groundwater. Some other tools were local cooperative solutions. That includes sort of the 30% across the board plans for overlying groundwater users in the Scott, as well as some other avenues, including tributary-wide local cooperative solutions, equal or better local cooperative solutions. And if folks can get everyone together in a watershed, there's a pathway for watershed-wide local cooperative solutions. Also prohibition on inefficient livestock watering, which can be especially important to flows in sort of, the spring redistribution period for juvenile salmonids, as well as getting fall flows into both watersheds to bring Chinook into the system. And like I said, we were collecting water quality data in both watersheds to really see what the impact was. So having that opportunity to understand the impact of these actions on water quality was super important. And I'm going to call these things that happened flow experiments for the purpose of science, but they were not intended flow experiments. One was a period of time where the Shasta River Water Association violated the curtailment and had a pretty big drop in flow that you'll see in a minute. And we were collecting data while that was happening. And then there was a flow recommendation put forward by Mike Podlat to lower the summertime minimum flows in the Shasta from 50 CFS to 30 CFS. So we'll get into that in a minute. So here's a hydrograph that shows flows in the Shasta River in 2022. And that red line is the emergency minimum flows. And you can see in the Shasta River, I would say the folks out there did a pretty good job of managing flows for the most part, with that blip with Shasta River Water Association that happened in late August. Generally speaking, we were able to meet the minimum flows with some jitter. So zooming into this period of time where the curtailments were violated, Shasta River Water Association violated the curtailments between August 17th and the 25th. They dropped flows from about 46.8 CFS to as low as 11 CFS. So that's a big amount of the river that just went away. And as you can see from this chart here, so that gray line is dissolved oxygen concentrations. The orange line is temperature, and the blue line is the actual hydrograph at the Yreka gauge. And this is temperature and dissolved oxygen measured at Salmon Heaven. Like I said, that's a temperature compliance point. You can see that when the flows drop, the diurnal fluctuations and dissolved oxygen increase. So that means the maximums were higher, the minimums got a little bit lower. And that to me indicates increased biostimulatory activity. And then you can see temperatures as the flows dropped, maximum temperatures increased during that period as well, above 25 C. So it's interesting that something that's happening upstream, pretty far upstream, is having these effects pretty far downstream. So just to quantify this, you can see I've got 3 periods that I looked at: pre-diversion, during the diversion, and then after the diversion was ceased. I looked at 5-day periods to get sort of the 5-day rolling average, or sorry, just the 5-day average for flow, daily maximum water temperature, and daily maximum air temperature. And then I averaged the differences between the pre-diversion temperature and diversion temperature, and then the post-diversion temperature and diversion temperature for maximum water and maximum air temps. And you can see pulling all that water out of the river increased in-stream temperatures on average of about 1.86 degrees, and daily maximum air temperatures during that time only fluctuated by about 0.5 degree. So I spoke about the TMDL compliance scenario earlier. What that means is a suite of actions that the TMDL staff report indicates would impact temperature. So that includes increasing cold water flow from the Big Springs complex, increasing shade, and decreasing tailwater inputs. Since we're looking at a current sort of an intra-year analysis, you can kind of assume that there was no increase of shade during this drawdown period. You can also assume that, it is just one diverter. There likely wasn't a huge increase in tailwater during this time. That TMDL compliance scenario that looks at all of the suite of actions resulted in a 4.14C reduction from baseline conditions looked at in the TMDL staff report of the 5-day average maximum temperature measured at Salmon Heaven, which is where these temperatures were also measured. So in my mind, looking at this data, considering that the daily maximum air temperature varied very little across the study window here, and the daily maximum water temperature showed a pretty significant change, it's pretty clear to me that this change in temperature was driven by flow more than anything else. Getting into the Podluck recommendation, I'm really going to do a quick job of explaining this. I have a memo that Brian McFadden and I worked on to really look at this recommendation in depth, and I'm happy to send it to anyone who'd be interested in it. It's also is going to be included in sort of the package of materials that the state board is going to be looking at when they're thinking about readopting these regulations. So essentially, the recommendation from Mike Podluck, who's an aquatic ecologist, was to lower the summertime minimum in-stream flow requirements in the Shasta from 50 CFS to 30 CFS. That memo was provided to the state board on June 16th, 2022, and it was prepared by Mike Podluck on behalf of multiple irrigators in the Shasta and the Siskiyou County Farm Bureau. And in that, he analyzed McBain and Trush's 2014 report on the Shasta River Canyon in-stream flow needs. And so the state board came to us at the regional board to analyze what the water quality impacts of a potential 30 CFS summertime flow target would be compared to the 50 CFS. So we looked at 3 different flow regimes. One was a pre-curtailment 2021 July flows, also the post-curtailment 2022 July flows. And then I looked through the hydrograph, which you can kind of see here for a period where we had July flows, most comparable to Podluck's recommendation of 30 CFS. And that looked like around July 18, where we had flows in this window. So it's hard to see, but this little bracket is, I'm pointing at the wrong screen again. This bracket between this red box here is 25 CFS to 35 CFS. And you can see in 2018, there's a good chunk of flows here that fall within that bracket. So I kind of zoomed into there, and I wanted to look at maximum temperatures, but at Salmon Heaven, and then also weekly maximum temperatures across the Shasta to see if there's any sort of transect change that we can see. So the results of this analysis, when we're looking at average daily maximum water temperature, 2018, the date range that we're looking at is July 14th through August 3rd, where the average daily flow was about 25.5 CFS seen at the Yreka gauge. Average daily maximum air temperature, 38.6. Daily maximum water temperature for that on average was 26.7. Looking at in 2021, July 10th to July 20th, average daily flow was about 18.5 CFS. Daily maximum air temperature was just 0.1 C off of the 2018 daily maximum air temperature, so 38.7. And you can see the water temperature there is a little hotter, 27.8 on average. In 2022, during curtailments from July 10th through July 20th, Average flow was about 46.2. Daily maximum air temperature was 38.6 once again, and daily maximum water temperature was 26.0. So one of the important parts for me in looking at this is really to understand, can we tease out the driver of maximum air temperature and just see if we can minimize our confounding variables and focus in on what flow may have been doing. And so, in the end, all the study windows had relatively similar daily maximum air temperatures. And I should mention these temperatures are measured from a weather station located at the Yreka gauge. So in the canyon, pretty close to salmon heaven, not directly next to it, but in the same general vicinity of the Shasta River. So I would assume they'd be fairly similar temperatures at salmon heaven as well. So there's similar effects of atmospheric temperature on in-stream temperature for all these study windows. The 30 CFS recommendation did show a 1.1 C reduction in average daily maximum temperature over 2021, but the emergency flow of 50 CFS showed a 1.7 C reduction, which is a little bit better than 1.1. Looking at maximum weekly maximum temperature, this is where we get a pretty noticeable difference between the three scenarios. The 2022 maximum weekly maximum temperature for the 50 CFS flow showed a consistent improvement across the entire Shasta River from about the confluence of Big Springs downstream, about a 22.41 degree reduction in maximum weekly maximum temperature. And so just to give you some context to kind of get into this, the x-axis on this chart is approximate river mile from the mouth, and the confluence of Big Springs is upstream of river mile 25, but not too far upstream. So you can see downstream of Big Springs, there's reductions across the board, which shows that the power of the cold water coming from the Big Springs complex. With the podluck recommendation, you see some improvement between river mile 25 and river mile 15, but after that, it pretty much goes to the same level of temperature, same level of heating as you would see in the 2021 baseline flow case. And, the blue line is curtailment, the gray line is podluck's recommendation and the approximate flows for that. And the yellow line is the baseline of 2021. The reason for the greater decrease with curtailment, I think we hypothesize, goes back to the increased water coming from the Big Spring complex. With BSID being curtailed, it appears from a lot of the data that we have, there was much more water coming out of the Big Springs complex, on the order of 20 CFS or so, depending on day. It is really hard to gauge Big Springs Creek because of in-stream aquatic vegetation, but we were able to at least get stage measurements on an ongoing basis. And, this additional cold water moving down increases both the velocity of the river because you got more water going down the channel. And with that really cold water coming out of Big Springs, there's more thermal mass in that increased flow. And so it's more, it buffers change from heating a little bit better than warmer water would. And so, this 50 CFS flow may have provided more available habitat downstream of the Big Springs confluence to support over summer rearing of juvenile salmonids. And sure enough, CDFW in 2022 was able to get out into salmon heaven on July 27th. And they developed a field memo that showed that there were steelhead at salmon heaven, potentially hanging on to some cold water refugia and utilizing that. So that's another line of evidence that I think indicates that these 50 CFS flows hopefully made some of that cold water refugia more viable. So some of the conclusions from this, 30 CFS may provide reductions to the 2021 baseline, but less of a benefit than 50 CFS. The maximum weekly maximum temperature analysis shows that 30 CFS provides no discernible water quality benefits over the 2021 baseline, starting at about river mile 15, and the 50 CFS appears to be more effective to preserve cold water to the mouth. And we hypothesize that that's due to reduced travel time, like I was said, like I said, potentially some reduction in tailwater inputs due to reduced water use because of curtailments. And that may have preserved some local cold water inputs, providing refugia downstream. Looking at the Scott, it's a little bit more of a complex picture. Again, this is that same hydrograph with the red line showing the emergency minimum flows, but this time the hydrograph is the Scott. And around early July, you can see, went into the wrong screen again, the flows dive under the emergency minimum flows and then never recover. So the question is, did we see any sort of water quality or in-stream benefits from these emergency regulations? And so here's a couple rivers, a couple photos from the Scott River downstream of Young's Dam. August 11th, 2021, you can see this isolated pool is connected by, well, I guess it's not isolated, it's got a little rivulet that's maybe been connected through from the upstream part of the river, but really very little water, whereas in August 17th of 2022, significantly more wetted area exists at this reach of the Scott. Similarly, further downstream below Eller Lane, August 11th, 2021 is just dry as a bone. You can see the T-post for my logger setup is there in the dry riverbed. But in August 17th, 2022, that same area where that little bush is by the tire has a isolated pool that's likely being fed by groundwater inputs. And we were able to get some data from one of the groundwater wells near Black Bridge, and Black Bridge is now painted silver, so it's a historic name about the color of the bridge, I've been told. You can see in 2020, the maximum groundwater elevation, the deepest it got was about 17 feet below grade. In 2021, it was down near 19 feet below grade. And then in 2022, despite less water incoming, less snowpack, less precipitation, it's more around 16 feet below grade at its maximum extent. So there's a couple of benefits to this. This may mean that there's more water available to riparian tree roots throughout the year, which would mean there would be less of a drought impact on these riparian trees. That's kind of spitballing there, but if groundwater level's higher, it's likely that the roots are able to access it for a little bit longer before it drops below them. And, you know, this also means that there may be increase in groundwater inputs in some of those gaining reaches in 2022 rather than 2021. And what's driving this, to me, I think it's a line of evidence. I don't know that it's clear evidence that the local cooperative solutions established in the Scott, the 30% reductions did have an impact on groundwater levels and groundwater use. But again, this is just one data point. This is the only real-time data that the agencies have been provided access to as of now. So this is kind of what we have to go on for groundwater assessment. So we have more water in stream in 2022 compared to 2021, higher groundwater levels in 2022 compared to 2021. But if you look at this violin plot, that's temperature at different water quality stations, sort of a subset that I have of the larger group that I have, you don't really see an improvement in in-stream temperatures in 2022 as compared to 2021. You see it a little bit here downstream at Indian Scotty, but you know, upstream here, you've got this very long distribution showing some pretty high maximums, maybe, and some elevated minimums. This site right here, you know, you may have some improvement in minimum temperatures where things are a little bit colder, but maximum temperatures are higher. This red line is 20.3 C, which is the detrimental temperature to juvenile salmonids. So you just don't really see a good improvement. In fact, you see things being quite warmer in the East Fork of the Scott River. So that's not what I would expect. So I went down a rabbit hole, which I will take you down a small portion of it. When you look at the differences between 2021 and 2022, it really comes down to, you know, there were water efficiency gains, but there was also a lot more smoke cover in 2021 than 2022. So this is cumulative solar radiation calculated based off of the data that's collected at Quartz Mountain or Quartz Hill, which is one of those weather stations that I track. And you can see, if you think of the critical drivers of in-stream temperature, of incoming solar radiation, daily maximum temperature, and in-stream cold water accretions from groundwater surface water interactions, providing some sort of mediating force on maximum temperatures and providing cold water effusia. We can quantify that there was more incoming solar radiation in 2022 than there was in 2021 because there was less smoke cover. I have more information or more data that I've looked at that shows how many simultaneous fires there were, the duration of fires, but 2021 was a worse fire year than 2022. And so I think that kind of confounds looking at in-stream temperature as a direct measurement of success of these emergency regulations. So in conclusion, the curtailments plus local cooperative solutions and implementation resulted in an increased wetted area in 2022 than 2021. I think the evidence supports that. Elevated maximum groundwater levels in 2022 versus 2021, elevated meaning they were closer to the surface. It's very confusing when you're talking about groundwater. And then, but then in-stream temperatures were elevated in 2022, and that may be due to increased incoming solar radiation and higher maximum atmospheric temperatures from fewer smoky days. So that's what I got. I hope there's still time for questions. Like I said, distilling 3 years of work into 30 minutes is tough. So happy to take any questions.
All right. Any questions? Yeah. Dave?
Hi, Eli. Dave Webb. I'm
Dave.
wondering if you've had a chance to present this yet to the State Water Board, or if you're planning to, and what you think their response will be for future curtailments.
Yeah, they have seen all of this data as I've been working it up. The smoke is a bit new, so only some staff members have seen it, but they have that memo that I was talking about with Mike Podlek. The analysis of his analysis is, like I said, is going to be part of the materials that the state board looks at when they're considering readoption. And I think they go to inform both TMDL implementation in terms of the need for increased collaboration around groundwater management, especially in folks who are extracting groundwater from the Pluto Caves basalt, as well as any long-term flow efforts. So yeah, they're aware of this data.
Nadine Bailey, Family Water Alliance. You mentioned timber harvest, but are in any of your studies, are you looking at the federal land that is burnt to see if they're correctly assessing the severity of the burnt lands within that watershed? Yeah,
so we have a whole other unit in a whole other division in our non-point source unit. That's backwards. A whole other unit in our non-point source division that specifically looks at forestry practices and their impact on water quality. And they're currently working on a new federal lands permit that will look at the different discharges from forested lands managed by both the Forest Service and BLM, and also in some areas, not in this region, the National Park Service. So they are really engaged on fire management and post-fire cleanup. They do review the bear reports that come out. And I've definitely been advocating for them to also look at water quantity as well as water quality, because I think the literature shows that there's a pretty big connection between wildfire and water quantity that comes out of the rivers.
All right, Eli, thank you so much. Really appreciate the presentation.
Thank you.